All right, let's talk about pest management. But I want you to forget the simple picture of a farmer spraying a field. We're going to look at this as what it really is, a high-stakes strategic battle. It's this never-ending arms race, happening in fields all over the world between our cleverest innovations and their relentless evolution. So let's jump right in.
So think about this for a second. It sounds dramatic, but when you realize our entire global food supply is on the line, it's really not that far-fetched. You've got farmers out there on the front lines, fighting a nonstop war against weeds, insects, and diseases that are constantly adapting to every single thing we throw at them.
For the longest time, the playbook was pretty simple. Got a pest problem? Just spray more stuff on it, right? But we've learned the hard way that brute force just doesn't cut it anymore. That old approach is failing. Today's battlefield requires a much smarter plan. It's all about moving from a sledgehammer to a scalpel.
So let's break this down. To really get a grip on these new strategies, you gotta understand who or what we're up against. And at the very heart of the problem is one powerful, relentless force: evolution itself. At its most basic level, it's a zero-sum game out there in the field. Every single drop of water, every nutrient, every bit of sunlight that a weed gobbles up, that's energy that your crop doesn't get. And that's the conflict in a nutshell. It's this constant, fierce competition for resources, and it can absolutely tank your yields. So, the key word here, the most important word on this slide, is heritable. See, this isn't about a few tough bugs just happening to survive a spraying. No, what we're talking about is a fundamental genetic shift in the entire population that gets passed down from parent to child, generation after generation, until suddenly our best chemical tools just stop working. And this quote just sums it up perfectly. It describes what we call the pesticide treadmill, and it's a brutal cycle. Just imagine, the pests get tougher, so you have to spray more often. Maybe you use stronger, more expensive chemicals. All of that, just to get the same result you got last year. It's a losing game, and it's economically unsustainable.
So if that's the problem, how in the world do you get off that treadmill? Well, one of the biggest game changers involved a total shift in thinking. What if, instead of constantly trying to protect the crop from the outside, we could teach the crop to defend itself? Now that brings us to something called transgenic resistance. And I know that sounds like a mouthful, something out of a sci-fi movie, but the idea behind it is actually incredibly elegant. Scientists can find a really useful gene in a totally different organism, like say a common soil bacterium, and they can very precisely give that gene to a crop. And just like that, the crop has its own built-in shield.
So, how does this work in the real world? Well, let's take herbicide tolerance. You've probably heard of Roundup-ready crops, right? They've been given a special gene from a bacterium that makes them totally immune to a common herbicide, glyphosate. So now, a farmer can spray their whole field. The weeds all die, but the crop, it doesn't even flinch. It's an absolute game changer for weed control. And the same idea works for insects, which is just brilliant. There's this other bacterium called Bacillus thuringiensis, or BT for short. Scientists took a gene from it and put it into crops like cotton and corn. Now, these plants produce a special protein, and here's the cool part. That protein is totally harmless to us, to birds, to most other insects. But if you're a specific pest, like a corn borer or caterpillar, and you take a bite, that protein becomes a very specific poison right inside your gut. It's like a custom-built microscopic smart bomb.
Okay, so these crops sound pretty invincible, don't they? But remember what we said at the beginning. This is an arms race. Evolution always finds a way. So to fight back against evolution itself, we have to get really clever. And that brings us to a strategy that at first glance might sound completely backwards. It's called a refuge. You heard that right. The whole point of a refuge is to intentionally plant a patch of regular, non-BT crops right next to your fancy transgenic ones for the sole purpose of raising a healthy population of bugs that are still vulnerable to the technology. I know, it sounds nuts. Why would you want to do that? Well, it turns out it's one of the most critical things you can do to make this technology last. Let me show you why.
Let's imagine a scenario without a refuge. Farmer plants his entire field with BT corn. What happens? Well, out of millions of pests, maybe a tiny handful have a rare gene that makes them resistant. They're the only ones left standing. So who do they mate with? The other rare survivors. All their kids inherit that resistance gene. And boom! In just a few generations, the whole field is overrun with a super pest population and your expensive BT crop is totally useless.
But now, let's rewind and add the refuge. It changes everything. That handful of resistant bugs from the beet field, they emerge, look around for a mate, and what do they find? a massive population of regular, susceptible bugs living right next door in the refuge. So they mate, and because the susceptible gene is dominant, most of their offspring are now vulnerable again. You're basically watering down the resistance genes, keeping them so rare that the technology stays effective for many, many more years.
All right, so we've covered genetics. Now let's switch gears and talk about tactics on the ground. Because when it comes to weeds, it turns out that timing is literally everything.
This is a concept called the critical weed-free period. And a great way to think about it is like a crop's childhood. When a plant is very young, it's super vulnerable. And if it's forced to fight against weeds for light, water, and nutrients during that short, critical window, it gets stunted. And here's the kicker. That damage is permanent. You can never get that lost yield back. And as you can see here, that window is different for every crop. For something like maize, you're looking at maybe 3 to 5 weeks after the plant pops out of the ground. For rice, it might be a bit longer. Knowing this exact timing is huge. It means farmers can focus their efforts right when it matters most, saving time, money, and getting the biggest bang for their buck. And if you think a few days don't matter, think again. Look at this. Delaying your weeding by just 5 days, we're talking the time it takes for a single new leaf to grow, can cost you 2.5% of your total yield. That's real money right out of a farmer's pocket. It's a pretty stark reminder of just how important timing really is.
Now, even with all this cool genetic tech and smart timing, chemical pesticides are still a vital part of the toolkit. But, and this is a big but, we have to be way, way smarter about how we use them. It's not about just pulling a trigger. It's about being a grandmaster, thinking several moves ahead.
And being a strategist means knowing your weapons inside and out. So let's cover 2 crucial terms, mode of action and site of action. Think of it like this. The mode of action is the how. How does it work? Maybe it attacks the nervous system. The site of action is the where. Where exactly in the nervous system does it attack? A specific enzyme, a specific receptor? That small distinction is everything when it comes to outsmarting resistance.
So what's the secret weapon against resistance? It's simple. You have to rotate your attack. I love the baseball pitcher analogy. If a pitcher only throws 100-mile-an-hour fastballs, eventually the batter is going to time it up and hit a home run. You have to mix it up. Throw a fastball, then a curveball, then a changeup. In farming, that means using a pesticide from one mode of action group, then following it up with one from a completely different group. You keep the pests off balance, making it almost impossible for it to adapt.
Okay, so we've covered genetics, refuges, timing, chemical rotation. What does it all mean when you put it together? It means we have to stop looking for a single silver bullet solution. The future is about building a complete, integrated defense system for the entire farm.
And that system has a name. Integrated Pest Management, or IPM. Think of it like a coach's playbook. You don't just have one play, you have dozens. You monitor pests so you only treat when you absolutely have to. You use smart practices like crop rotation. You use powerful genetic tools and the refuge strategy to protect them. And when you do use chemicals, you rotate their modes of action intelligently. It's about using every single tool in the box together to create a defense that's so much stronger than any single tactic. Because at the end of the day, this agricultural arms race, it doesn't really have an end. The pests are relentless. They will always be evolving, always adapting. And so that leaves us with this huge critical question, not just for farmers, but for all of us who depend on them. As the enemy keeps changing, what's our next move? What new technologies and what new strategies will we need to invent to make sure we stay one step ahead?